Okay, class, remember that tomorrow we have a lab and it involves chemicals, so please wear the proper attire. I am not checking to see.
I feel like I'm forgetting something. Whatever. What's the worst that could happen?
Now, as a review, remember to know where the safety shower is, report anything that happens in the lab, such as accidents, make sure you disinfect your hands and area after a lab to make sure that you're not having any cross-contamination, have ventilation for airing out chemicals in the air, know where the emergency eye wash station is for washing off chemicals from the eyes, make sure the fire extinguisher is available to put out fires, always have a first aid kit to help with any injuries. Now, all you will need is to keep track of the chemicals used on the material safety data sheet that gives info on chemical products, such as the hazards, safe handling, and disposal, and make sure you follow the standard operating procedures in order to make sure the experiment is followed through correctly. By following these steps, class, you can ensure a safe and fun lab experience.
I'm kind of hungry. I just bought these chips. One bite won't hurt, or maybe 2 or 3.
Okay, class, now pour the oxygen into the hydrogen. It should turn red.
Wait, what's this charger doing here? I know I should clean this biohazardous material properly to prevent cross-contamination, but I wonder what happens if I put the charger inside the hydrogen.
Moments later.
Okay, now, what did I tell you guys about being careful? This all could have been prevented. You guys would have just listened to me. First of all, Daisy, you weren't wearing your lab coat, your safety goggles, shoes that cover your feet, and a hair tie to tie your hair away, because now you increase the risk of going into contact with dangerous chemicals that can either be flammable, corrosive, toxic, or radioactive. Secondly, Genesis, you were eating in class when I specifically told you not to. And you blowed up the school because you were playing with electronics. No playing with electronics. You guys are lucky that I had an evacuation plan. Now everybody follow my instructions and wash up while I report this. I don't get paid enough for this.
In the chaos of a high temperature zone, a battle rages. It's not just any war, it's a chemical one. On one side, carbon, a tough non-metal. On the other, a pair of highly reactive oxygen atoms. Together, they're headed for a molecular standoff.
I don't want any part of your reaction, Oxy. I've got my own stable structure, 4 balanced electrons, and I'm keeping them.
You're a ticking time bomb of electrons, Carbon. We're non-metals too. We don't give away electrons. We share.
We are here for covalent bonding, not war. Just look at the Lewis dot structure. You need us.
Carbon hesitates. He is the last carbon atom. He has chosen to the life of solitude. He doesn't want to end up like the others who got their electrons stolen from. Though he knows this is the rule. Atoms seek stability, usually through a full valence shell or an oxide. The heat rises, electrons start to shift. The war turns into a dance. Electrons shred. Bonds form. This is no longer a war zone. It's a molecular union.
Wait a minute. I just want 2 double covalent bonds. One with each of you?
Exactly. We both bring 6 valence electrons. You bring 4. Together, we form a linear molecule with the formula CO2.
We are a perfect example of molecular bonding, no ion formation, just pure electrical sharing.
Though no electrons were transferred, as in an ionic bond, the result is just as stable. A molecular compound held together by strong covalent bonds.
I get it now. You weren't attacking me. You were showing me how to become more stable.
Exactly. We're all non-metals here. Our bond isn't about strength through control. It's about electronegativity and cooperation.
Sure, our bonds are polar covalent. We pull the electrons a bit more, but we're not trying to dominate. It's about bond polarity, not rivalry.
And oxygen now drift calmly into the air, no longer lone atoms, but part of a stable molecule. The world sees them not as enemies, but as essential to life. Carbon dioxide, the product of a reaction and a story of formation.
I was afraid of losing myself, but I've actually become more complete.
That's just the beauty of chemistry. Reactions don't destroy atoms. They rearrange them into something new.
And now, as CO2, we play a part in photosynthesis and breathing in global cycles from war zone to essential compounds, all through bonding.
While the next time you breathe out, remember, even in chemistry, enemies can become allies. All it takes is the right conditions and a few shared electrons.
The five main types of reactions are synthesis, when two or more reactants combine to make one product; decomposition, a reactant breaking down into two or more products; single displacement, an atom replacing another one in a compound; or double displacement, two reactants exchange and make two new components; and combustion, a reaction involving oxygen that produces energy in the form of heat and light. How do chemical reactions absorb and release energy? Chemical reactions absorb energy when bonds in the reactants are broken and release energy when bonds in the products are formed. How can chemical equations help predict the product of each of the five types of reactions? Chemical equations visually depict the reactant/products of reactions between substances, offering insight into the transformations that are taking place. What is Avogadro's number and what is it used for? Avogadro's number is 8.0222 times 10 to the 23rd power, and it represents the number of particles in 1 mole of a substance. And a mole is just basically a measurement, like when someone says a baker's dozen, or like a foot. It's something used to measure, and in this case, the particles in a substance. What mechanisms allow us to utilize the energy of our foods and fuels? This is done by cellular respiration. It's a metabolic processes that converts the glucose/sugar from the food that we eat into energy, which is also known as ATP. What models can we use to predict the outcomes of chemical reactions? The law of conservation of mass helps us know what elements we should expect to see in the final product, because matter cannot be created nor destroyed, meaning that if we see a certain number of elements and these specific elements in the reactants, we should expect to see those same elements and same number of elements in the products in some way, shape, or form. Out of the five main types of chemical reactions, synthesis, decomposition, combustion, single and double displacement, the reaction observed in this chemical reaction is actually a different type of chemical reaction called dissociation, where a compound splits into two or more smaller components, usually in a reverse manner. Show. We're gonna be learning about chemistry, and we have contestants right now that are gonna come in, and we're gonna ask them questions about chemistry. They're gonna have to respond, and whoever wins gets to go home and meet my cat. Okay, now let's meet our contestants. From Atlanta, Georgia, we have Yellow Heart, Daisy, and Brandon. Hello. I'm gonna win. And then from Miami, Florida, we have Brenda and Karen. Okay, these contestants will now answer questions based on chemistry, and the one who wins will not only get a cash prize, but
factors that are necessary to consider when determining a chemical reaction at equilibrium are temperature, thermal energy, concentration of reaction, the presence of catalyst, and surface area of the reaction rate. While catalyst speeds up reactions by lowering the activation rate.
That is correct, yellow points. Now this is the big question. This is with 5 points, and winner takes it all in this case. Now the question is, what are the effects of not having a pH balanced skincare?
That's disqualification.
I'm sorry, Adams, but you clicked. You clicked to a buzzer before the timer ended. Therefore, I cannot. Now, yellow points. This is a make-or-break question. What is your answer? Reminder: you are 1 point behind Adams. To answer.
The skin barrier is affected in skin issues such as acne, eczema, inflammation, and bacteria begin to occur within the skin.
That is correct. You get 5 points. Okay, guys, that ends yellow points with 9 points. Now your cash prize is my Starbucks gift card. Thank you, thank you, thank you. And you guys get $1 each.
Thank you.
Yeah, you're welcome. Yay! Thank you so much for tuning into the Evan's Game Show. Can you please, contestants, please stand up in victory? Yay! Now you guys can parade around the school. You guys are masters. You guys are now labeled. You guys are now labeled masters of chemistry. You have won the title, guys. Now let's wave our contestants goodbye. All.
You guys suck.
Well, thank you for tuning in to this episode of Evan's Game Show, where we learn all about chemistry, and you get to get tested based on it for a chance to win a cash prize, as you just saw right now. Thank you so much for tuning in. I'll see you guys at the next episode.
I see the ocean where CO2 is high. Greenhouse gas, it's a deadly climate crime. I'm just trying to reduce my footprint, 'cause our oceans carry marine life. Fossil fuels burning into deadly sin, drying out the coral reef like crazy. But we can shift our energy from within to renewable energies like solar. The hills are calling the oceans. CO2's rising, it's a toxic strain. Trying to reduce my carbon footprint, but it's getting hard to breathe out. It's hard to live 'cause it's toxic, it's killing life, yeah. The hills are calling the oceans. CO2's rising, it's a toxic strain. Trying to reduce my carbon footprint, but it's getting hard to breathe out. It's hard to live 'cause it's toxic, it's killing life, yeah. Photosynthesis loads, it's just natural. When the climate's failing on the down low, but we can change the absorption now. Lee Shadowler's principle shifts the scale. Whenever certain conditions hit, sea currents mix, it's thermal dissociations, that's just chemistry. Let's reduce emissions, take a step back. The hills are calling the oceans. Hey, CO2's rising, it's a toxic strain. Trying to reduce my carbon footprint, but it's getting hard to breathe out. It's hard to live 'cause it's toxic, it's killing life, yeah. The hills are calling the oceans. Hey, CO2's rising, it's a toxic strain. Trying to reduce my carbon footprint, but it's getting hard to breathe out. It's hard to live 'cause it's toxic, it's killing life, yeah. The seas have lives. Who are you to burn? Who are you to burn? Hide your print. Hide your print. Only you to change. Only you.
Oh my god. If I'm on. So how was you guys' day?
2-1.
Oh wait, sorry.
Bruh. Go.
I'm sorry, I can't get her to be quiet. I'm so sorry.
Shawty's like a melody. Shawty.